Okay, my name is John Paoluccio. I'm president of Inventive Resources Incorporated in Salida, California. For the past about 5 years, we've been working on a innovative solution to tackle aquatic invasive plants using a non-chemical method called UV light. And I'm going to go through the last few years of what we've been working on, and we recently got a really big project in Lake Tahoe where we're doing this technology along with other technologies. And I'm going to give a little background of UV light and and how we're using it to kill aquatic plants. So current treatment methods, this is common. You've got herbicide applications, you've got mechanical harvesting, you've got something called barrier mats where they cover the plants with a blanket, and then just hand removal. And you know, these costs can range up to $35,000 to $50,000 an acre. So it is very costly to do a lot of these applications, but that's what's currently being done to handle aquatic or even terrestrial plants. So years ago, in college, I worked at a cave my summers, and I would spend time trying to put lighting systems in different caves, and algae was a big problem growing on the walls. And so we came up with a method to kill the algae using UV light. So that's how I got started in this. And then when I bought a place in Tahoe, I learned what they were doing out there with all the aquatic plants. And I said, there's got to be a better way. And one thing led to another. And I took my experience using UV light in caves, and I built the demo and shared it with TRPA and got a chance to do a pilot project in Tahoe. And that's how I started. There's been a number of reports and publications done on this now. We've, like I said, been doing this since 2016. And TRCD and the league were the first, or not, TRCD was the first one to give me a project working with TRPA on a small 1 acre plot. And since then, we've done about a dozen different sites now where we're working in canals. We've worked in ponds, a number of areas in Lake Tahoe. And so we're sort of expanding this technology, and I can be glad to share the links to these different reports and publications. And then feel free to ask any questions during the presentation. University of Nevada started working with us a few years ago on testing UV light on turions and smaller different plants. And so they spent 2 years doing different studies, and this was a few photographs from what they did on turions. Turions is basically a seed from something called curly-leaf pondweed, and it's a very rapidly aquatic plant that's taking over a lot of the waterways. And so we tested UV light on the seed and then different aspects of the growth, and they determined when it was best to treat these plants. And you know, first we started with the turions, and it had no effect because of the hard shell. It was light did not penetrate. And so they would sprout after treatment. Well, if you treat them too early when they're in this stage, it seems like there's enough energy still in the turion to shoot out another sprout. The most effective was when the plants were about 1 foot tall, and that's around in this stage right here. And we did about 15 minutes of treatment, and then you hit them one more time throughout the season, and that pretty much caused them all to drop. So from that 2 year study we did with UNR, we were able to learn when to treat these plants along with all the other ones, and that was really helpful for me, so we're not just spending time in the water. Equipment that we've launched last year, or I guess this year, 2022, were these 3 vessels, and this one's an 8 foot by 40 foot. This is 16 feet by 40 foot, and this is a little autonomous one that we made that works in marinas. So, and I'll go into on how they work in a moment, but basically they're just a large bay of lights, and you just drive right over the plants, lower it down, and either move really slow or just stop and go. And that's how all of this technology works. And you've got to get the plants you need to get the array within about 6 inches of the plant. So that's important to realize. You just can't scan the surface. You actually got to lower it down and then move forward.
How long do you keep there?
15 minutes is what we typically have been doing, but sometimes we do less and we do it twice. So if we want to do an area of 5 minutes, we may hit it 3 times. So we've tried all different technologies, all different methods, and we're learning that 15 is pretty good. And that's pretty what we're building into all of our estimates is that time. Yes, in some areas it takes a lot longer, and some we just breeze through it. If our sonar's not picking up a lot of plants, we'll move faster. If we find that there's a large area, we'll still do 15-minute treatments, but we'll move slower. Like we'll only transition 20 feet instead of 30 feet or something like that. Everything's on a trailer, so we can move it pretty much to any sites. Some can be lifted up by a crane. Other ones we require a boat dock of some sort to put it in the water. This is the little one that we launched at Lakeside Marina. It's a marina right at South Lake Tahoe. And so basically the manager would just move it around from slip to slip. So as the slip was emptied, they would move this device into that empty slip, turn the lights on, lower it down to be about 6 inches above the ground, and let it go for 20, 30 minutes. And then he'd move it over whatever schedule they have. And that worked really well this year, especially with the low water. If you've been to Tahoe, we've lost a lot. So we had a really hard time treating a lot of these areas this year because of the low water. We've added tracking to the boats, and that was the first few years. It was very hard to monitor what the employees were doing because, you know, I'm sitting at a desk, they're sitting on the boat. How do I monitor what they're doing? So we added a lot of sophisticated monitoring equipment, and I could tell from my cell phone exactly, you know, what area they've been in and how long they've spent in these different areas. And so this is just sort of a whole season put into one map, and it shows the areas that we could not reach due to low water or boats being parked there. But the red is what we did hit. So this is just something we did this last year. So that shows the difference of where we weren't treating, you know, going back to this is that area right around this area. But you can see the plants where we didn't treat versus where we did treat. And so visually, it looks really good from an aerial view. This sort of gives photographs of what it looks underwater. So this is a non-treated area. This is 2 weeks after we treat. Everything sort of just drops down. And then after 3 weeks, it just seems to decompose and then turn into this very fine dust. And there's really no hauling out of plants. There's no plants floating to the surface and you have to scoop them out. They pretty much decompose on site. And that is a big thing when you talk about the tons and tons and tons of plants the harvester is pulling out. Then they've got to haul it up the hill and drop it off somewhere. This is sort of natural. We realize every winter this happens naturally anyways. We're just speeding up that process. So we're not adding more to the environment. We're just sort of speeding up the decomposition process that happens naturally over winter. And so if you hit it early, like June, you're dealing with a fraction amount of plants that end up in our waterways.
Have you noticed, because obviously there's a seed bed as well, or
Yes.
I'm just curious if you've noticed, I guess, how long have you been doing it for? Have you noticed long enough where you're actually impacting
Yes.
reducing it over time? Are you getting there?
Yeah, UNR, that's what UNR focused the first couple of years on. And they, like I said, in one of their publications, it does show a reduction. What we did notice though, right after we treat, we get a huge explosion of plants. And everyone was like, oh, it's not working. I was like, it's actually working great because I've just launched year 3 seeds to this year, where you've got these seeds that have built up. They have 10 years of seed banks out there. So I look at quick growth coming back as a positive because you've knocked down this canopy that normally those plants that were hiding down here would never have sunlight to grow. I've excited them now in August and you hit them again in October. So you've actually sped up that process. And the goal is not to let them seed. So if you can treat the plants before they form, and they usually form in July, you treat them in June, that whole seed bank is not going to happen. You can see the little black dots here. Those are all mature seeds. So, you know, this area we treated too late. But if you treat them when they're 1 or 2 feet tall, you really can absolutely start that clock of, are we solving this problem? Let's see if I can make this clip work. Okay. So this is 29 days after treatment. So I'm just going to drop the camera right sort of in this zone, right around in this circle. Not super clear, but this is an area we treated. Doesn't get everything the first time. This is first treatment, but so see what's brown, which is impressive. That's right there, but it's pretty sparse, and then all of a sudden, you hit the non-treated section. That's what we dealt with. You can see the tremendous reduction of plants we've done with one treatment of UV light. And I just think that's impressive to show what that waterway would look like without UV. So it's pretty obvious that we had a positive effect. This is another, something called BioBase, where they take a sonar and they do some scanning and they create these maps. But this was an area we did a few years ago. And our focus was this square. And then we transferred over here to treat this area. Water was super shallow, so we didn't get very good treatment up here. But if you look at this map, this green area is no plants. And what's even more interesting is even captured us driving across here and doing this area here. So just even 1 minute of treatment had a big impact on the plants that we didn't even mean to treat this area. We just would let the lights on to transfer right here, and we actually killed all these plants too. So it just sort of shows the effect of UV light on how even in shorter movements, it's still effective. This was from the UNR study. They show basically the gray line is non-treated or the before, and then we started in July, and after our first treatment, it dropped down. Our second treatment, it went down to this level, and by September 20th, they pretty much found nothing. And so that was really impressive. Come the next year, we did have more plants, which is what I expected, because we've given those plants and we've not treated yet right here yet. So we saw an increase of plant growth, but basically what I said before is I think that's because we basically destroyed the canopy and you had all those fresh turions coming up with nothing impeding them. So you had more growth initially. I think we treated that site in August. We did a late treatment, but we knocked it back down. We're seeing the same kind of pattern throughout all of our treatments. These are some more aerial views here. This is a channel. This is a barrier mat. You can sort of see they've laid a rubber mat down just as a sort of a guide. And this is loaded 8-foot tall plants throughout here. And then this is after 2 treatments. And you can see a pattern here. We sort of messed up on our movements, but you can see how some plants survived in these different patterns. And so we learned that the movement of the vessel wasn't designed right. We need to shorten that up and have better treatment, but we had fairly good effect. And this area was back here was all done with hand removal. So they had divers out here suctioning this up, and that's this area here. So you can sort of see the difference between the 2 technologies. And this took about 2 weeks. We did about 1 week, and then we came back a few weeks later and did the second. That's our grid pattern that we follow. We just actually start from one end and transfer. We leave one side open at a time so boats can pass, but we treat one side and turn around and do the other side so we don't block the channel. That's just showing an example of our movements. A couple more photographs of before and after. That's about a month period of difference. So it shows a marina wall where we weren't able to get the boat that close, but we stopped right here, and after 2 months, this is what it looked like. And did we solve it? No, but we absolutely controlled it. So those plants are not going to get sucked up in people's boat motors and spread across the lake in your waterways. Today, because of the drought, we now have dirt here, but in a few years, it's going to be interesting once we see what actually comes back and how we affected the seed bank. A few project photos that's taken this last year, or this year, I guess. And we had 2 boats running. There's a small one and there's the big one. Then for the last 2 years, we worked with in different canals. We did something with the Fallon Canal with UNR. And this was the first time we did a dirt line canal. And so we had a crane pick this boat up, drop it in, and we made these big indexing wheels, as you can see. And we got a funding through UNR and other groups, but they basically, this indexes the boat to be within that channel. So we could treat, scoot the boat over 4 feet, and we were able to do about a mile of treatment in this one canal. And UNR was going to write a paper on it, but the problem was the canal got emptied right before they're doing their last bit of analysis. So we lost a lot of good data from that. I think it was during the fires and other things happened, but we do have 2 years of work with Fallon on this, and it was a really good study. Then we did one with Contra Costa, which is a cement line canal. We did about a mile of treatment, a little bit different vessel. We had to change our wheels to be at an angle, so we didn't get stuck, but the same process. We actually went right down the center and very easily did a mile, much quicker with cement, because you don't have to worry about getting hung up on anything. That was successful. And then this last year we did something with in LA where they had a lot of these screens. So they're spending, thousands of dollars having people rake these things, and they get blinded with plants, and they have to have a lot of labor issues where someone gets hurt. And one pilot project will help reduce the amount of hand raking and pulling they've got to deal with these screens. So what we did a low voltage system down here, and it just lays at the bottom of the screen, and they drop it in with this crane. They still can rake, but after the photographs that were taken, there was no plant growth on the front of this. So we actually put these lights behind. So any branches that come through, they still hit the front of the screen. Our lights are back, 4 inches from the front of that screen. So they're able to kill any plants that rest against it. They just decompose. And so you've got a lot cleaner area. And so that's going to be a 2 to 3 year study before they have us outfit all of them. But this idea is to reduce the amount of labor it takes to clean the screens. And this can be done with fish screens and all the other things we put in line with our canals to help reduce the amount of blockage and other things that plug up the screens. I have a few other videos, but I think we can just talk and open up to questions if you have any. And yes.
Yeah, I have a question. I'm curious, so the areas that you can't get to with this equipment, have you guys thought about developing like something smaller? So like for, something that floats so a homeowner could actually buy it or use it?
That was the first, yes, the autonomous one was I'm on my way to that, but I'm doing a mat right now. So I've got these, we just ordered them, they're very small, like LEDs, and they're UVC, low voltage. The idea is you can inflate something and float it into a slip, deflate it with sink. So put that in the homeowner's control. Yeah. I've been working on that. It's funding, it's hard. These are expensive. Yeah. So, and I don't have any projects that are lined up. I've had homeowners say they would buy one, but the cost to develop is very expensive. And you look at my company. Yeah. I'm a small company. I developed a few stormwater projects, but we have a small engineering company, and I've literally, once I had the opportunity to do this project, it's pretty much taken up all my time since 2016. And my wife's going to kill me. I think we have 5 boats in my yard and a number of other things, but every year we get closer, and every year we get more technology. But I am working on a mat, and this year we'll be testing on the weak side.
So unfortunately, Carson City folks couldn't be here today, but they have been experiencing a huge problem with Eurasian milfoil starting in the river channel. It came from the Mexican dam ditch initially, and the ditch is really small. Mm-hmm. So, putting in, your large technology probably wouldn't work because it's probably, 3 times the size of this table maybe wide. In the ditch itself, but the actual river channel is getting really, really clogged as well. And that during the spring, you could potentially, maybe not, it depends on how big our spring is, really. But kind of what, have you thought about doing it in a river? And what would be, that's the other thing is like when it's growing, it's usually super shallow. Like when it's really growing.
A few years ago, I was approached by a group here in Carson, and I gave a proposal. They accepted it. It was all ready to go, and I'm the one that backed out.
Oh,
because I gave her a proposal without seeing the site. I went there and I looked at it and it was literally a ditch. And I was like, wait, nothing I've made would ever fit in here. And they were explaining to me it was a canal. I was like, oh yeah, it was a, you know, a canal, and I went there, there was tree branches, there was bushes, and there was, and I just really could not accept the fact that I would fail something that so early on in my technology, I didn't want it to fail.
right.
And so I was like, let me get further along. Now I am further along. I probably could propose this mat that you could drag behind an ATV or something, but we're still not really there yet. And it's really hard. This is meant for open water areas. To go to something that's so many obstacles, I think there's other technologies that we could test there. But I would still love to play a role on sharing what I do know now about these things. But it's, when you talk about a lot of branches and sticks, and you can't have something sophisticated like that go through that and have good control. But you know, the larger
river itself, though, maybe
river can be done. Yeah,
depends on where.
Depends on the flow rate, but there's areas there, or I'm more focused. I really like the idea of these screens because that is one of the areas that plug up. And if you could do something where, in addition to the automatic raking, if that's what they have, that would help reduce it. That's a great idea because it's hands off, and you plug it in and you clean it once a year. So that's the kind of technology I want to try to aim for. But the ditches are tough. I've been to a couple of them now, and I've been asked about it because it's an ongoing problem. And I think part of it is you need to clear it out somehow and put something shaped to pull down that row, and that's just a little tricky.
Right.
So just curious, the milfoil itself is life cycle. It can spread through roots, it can break out from the nodes, and it can reseed, it can sprout itself, and of course there's a seed too.
Right.
At the same time, when you're looking at like an infected ditch area or an infected area, if you drain the ditch, would it be useful at all to like have like a little cart with lights on it or something like that? You could drive down and try to immediately hit kind of the plants that are to make sure those nodes aren't
They gotta be
viable.
green. They can't be brown. They have to be alive. You don't want to get old growth plants.
Yeah.
I've noticed, beginning of the season is great. Everything's fresh and bright green, and you get towards August, September, and they've turned these brownish color. It's almost a layer of protection they've built onto them. They're dying. So it really depends on what age the plant is, but I would definitely say if there's an area of focus, maybe choose one area, do a pilot, do something smaller, and see the effect of treated or untreated. Those are better now. I did develop these 4 foot by 4 foot bays that we float around to treat algae and stuff like that. So the technology is getting better. It's just something that I was too ambitious to try to do miles of this stuff, and it's just not practical. I'd rather focus on a smaller area and let your teams operate and not rely on my teams, because it's more of, I want to develop a product that someone uses versus having me operate it, and that's got complicated.
So below the Hunting Dam, they're also seeing just a big boom in Swago pondweed, which is, I think, is a native, but it's really thick in the channel downtown. It's a nuisance now. This works on multiple species.
Pretty much anything. I mean, we've tackled some plants with thicker stalks, like a Richardson pond would take longer treatment. I have a video where we treated an area, and after 2 weeks we went back and we saw these plants down, but all these plants that are unaffected. And I went back to look at the video and I was like, oh, that's all Richardson. So, one treatment got all the milfoil, got all the curly leaf, the coontail, but didn't touch the Richardson. Took us 3 treatments to get the Richardson. And they're like, well, leave it. I was like, well, it will come back, don't worry. It usually does, but we wanted to clear that channel out and make sure nothing was there. So that was our goal. But Richardson is a little, stronger plant, and we'll find that through nature.
Is there anybody online that has any questions? Please feel free to unmute yourself and ask a question.
I got something. I just brought it because I saw this talk was coming up. There's this prize funding from the Bureau of Reclamation. Did you see that? It's like veg out
I heard it last year they were doing it. I didn't know it was out.
I think it's out, and they said they have like 345,000 in prizes to like for like kind of I think technology like this to get away and just focus on water quality. And I wasn't aware if you were aware.
No, I'm not.
It's
I
out.
wasn't. I didn't know it was actually out, but thank you.
I'll give you what I have on it too.
Okay.
And then I was wondering, is there any like kind of like hoops you have to jump through with EPA? Because I know like sometimes they with those devices, you know, you have to get them registered. So
I am
is it-
registered. I'm a pesticide.
Okay,
so,
cool. All right.
We have a registration number. As long as I operate it, I'm pretty much in full control. Once I sell it, it's a whole nother
Yeah.
ball of wax that we have to deal with. So that's why I'm sort of limited. I'm not advertising. I'm not going and selling these boats. That's really hard. But my goal is to find an investor at some point to help us build a fleet of these things and make them where you could put one in every marina. If every marina would have one of these smaller ones, it would be great because they would control the plants. And that's where really the plants will really start to breathe. They start growing, they get chopped up, and they spread throughout waterways. So if you put one of these in every marina, it makes perfect sense. One person can operate it. They're propane, gasoline, diesel, we can make them run off electricity. So there's a lot of different ways to make them operate. So I heard about that. I didn't know it was actually out yet. So
Okay. Yeah. I'll give you this.
Thank you.
Yeah.